Hello, and welcome to Discussion Forum number 4 of 4 for the spring semester of Net 126. My name is Millicent Edwards, and thank you for scrolling through the questions and joining me on this brief journey of subnetting. I hope some of the basic principles I have included will help you refresh and renew your minds in preparation for the inevitable certification exams in our future. You probably already know how to perform these tasks, but this is simply a review. Thanks again for clicking the link. Let's revisit subnetting and practice a little. You may not have done any subnetting since Net 125, but you must know it to be a CCNA. This activity has been modified from its traditional classroom activity format to a Moodle discussion forum. Don't be scared or intimidated, just jump in and we will help you. I will assign each student a subnetting problem. You are to explain in the fullest detail possible, with binary bits and all, how to complete the problem. Do not simply post the answer. If your explanation is not sufficient, you will be asked to provide more detail. In this presentation, I'm going to reveal the question I was assigned, review some basic concepts, then complete the steps to find the results for the subnetting question I was assigned. So what's the question? Our illustrious instructor, Ms. Kendra Faulkner, assigned me the question, what is the first valid host on the subnet that host 172.29.247.187/21 belongs to? Okay, this slide is a very basic Net 125 info type slide, so if you already know this information, you may want to advance through to the next slide. What is an IP address? An IP address is a 32-bit or 128-bit address used to uniquely identify a device or interface on a network that uses TCP/IP protocols. Generally, the first numbers identify the network and the last numbers identify a host. So as you can see displayed here, in this example, our dotted decimal address is 172.29.247.187. Now, since this is in dotted decimal format, a little bit later on in this presentation, we will have to convert it to binary to eventually come up with our information for our answer. What is a subnet mask? A subnet mask is a number that distinguishes the network address and the host address within an IP address. In this example, our subnet mask is represented by /21, and that indicates the subnet prefix length, which we will also calculate later in the presentation. On the previous slide, we briefly mentioned the need to convert our given IP address and subnet prefix from dotted decimal to binary. Well, this slide is a quick refresher. We're just going to focus on the first octet of the IP address, which is represented by the base 10 number 172. Divide your base 10 number by 2 until your dividend is 0. As you divide, the bit is given the value of 0 or 1 based on whether the result of the calculation leaves a remainder. If the base 10 number is evenly divided and results in no remainder, then a value of 0 is assigned. If there is a remainder, then a value of 1 is assigned. Write the result in order from most significant digit to least significant digit as shown in the diagram. Let's begin with 172. Divided by 2 equals 86. There's no remainder, so it's assigned the value of 0. 86 divided by 2 equals 43. There's no remainder, so it's assigned the value of 0. 43 divided by 2 equals 21.5. A remainder exists, and it's assigned the value of 1. We continue this process until our dividend is 0, and then we list our numbers in order from most significant digit to least significant digit. So 172 in binary is 10101100. We will later have to convert our IP address from binary back to base 10. To do that, we can look at our binary numbers review chart and our binary number in order from most significant digit to least significant digit. In every place where there is a 1, we're going to add that value. So the corresponding value of our most significant digit is 1, and that value is 128. So we will add 128, 32, 8, and 4 to return to our base 10 number of 172. So on this slide, I have displayed the IPv4 address format, and I have calculated my entire IP address from dotted decimal format to binary. So the key review takeaways from this slide are that there are 8 bits in 1 byte and 4 bytes equal 32 bits. The IP address consists of 32 bits divided into 4 octets, and the subnet mask indicates how many bits are used for the network portion. In this case, in our problem, it's 21 bits. Calculate the subnet mask in binary. A /21 subnet mask means that the first 21 bits of the IP address represent the network portion, and the remaining 11 bits represent the host portion. To calculate the subnet mask in binary, you would have 21 ones followed by 32 minus 21 zeros. 32 representing the 4 octets at 8 bits, minus 21 and 21 bits representing the network portion equals 11 bits representing the host portion of the subnet mask. The next step is to identify the network address. To determine the network address, the information technology student should perform the bitwise AND operation. Bitwise ANDing means to compare each bit of the binary IP address with the corresponding bit of the binary subnet mask. If both the bit in the IP address and the bit in the subnet mask are 1, the result in the network address is 1. Otherwise, it's 0. As you can see here, we have the binary versions of our IP address, subnet mask, and our network address. Let's see how we determined our network address from the IP address and the subnet mask. In the first position of the first octet in our IP address, we see the value of 1. In the first position of the first octet of our subnet mask, we see the value of 1. Since both of these values are 1, the corresponding value in our network address will be 1. In the second position of the first octet of our IP address, we see a value of 0. In the second position of the first octet of the subnet mask, we see the value of 1. Since the IP address second position value is 0 and the subnet mask second position value is 1 and they're different, our corresponding network address will be 0. Interpret the results. The result of the bitwise AND operation results in the network address. And you have a few seconds here to see if you've gotten your answer correct. In the result, the first 21 bits remain the same as in the IP address, while the remaining bits, the host portion, become all zeros. Converting the binary result back to dotted decimal gives us the network address. Network address in dotted decimal, 172.29.240.0. Therefore, the network address associated with the IP address 172.29.247.187/21 is 172.29.240.0. Calculate the first valid host. To find the first valid host, increment the network address by 1. Since the first address is the network address itself, the first valid host will be the next address, 172.29.240.0 plus 1. The first valid host on the subnet that host 172.29.247.187/21 belongs to is 172.29.240.1. In summary, to calculate the first IPv4 address of the first host on a given subnet, display the IP address in the desired format, perform the bitwise AND operation, identify the network address, interpret the results, calculate the first valid host. Thank you for joining us, and happy subnetting!